What type of XML document is this? Option A, well-formed XML. Option B, valid XML. Option C, not a well-formed XML. Option D, none of these. Here, one XML document is given. An XML document is valid if it contains a root element. Root element must be there, and all XML must have a closing tag. All the XML elements should have a closing tag, and the XML tags are case sensitive. XML elements must be properly nested, and the XML attribute values must be quoted. An XML document is well formed if it contains a root element and all the elements are properly nested and all elements should have a closing tag. If these conditions are satisfied, then that particular XML document is a well formed XML. But if we see this given XML document, we can see that there is no root element for this XML document. So we can say it is not a well formed XML. So here option C is the correct option. Solution of all ambiguous statements is in which of the following phases? Option A, design phase. Option B, testing. Option C, analysis phase. And option D, coding phase. Here resolution of all ambiguous statements should be made in analysis phase only. Why? Because if we ignore any ambiguous statements in analysis phase, those ambiguous statements will be continued till the coding phase. So those ambiguous statements should be eliminated at analysis phase only. So here correct option is option C. How many integral solutions are there for the equation x1 plus x2 plus x3 plus x4 plus x5 is equal to 30, where xi is greater than I for I is equal to 1, 2, 3, 4, 5. Here we can model this problem as distribution of 30 similar balls into 5 different boxes. Here x1, x2, x3, x4 and x5 are considered as 5 distinct boxes, and 30 is nothing but 30 ones. That means 30 similar balls. So we can model this problem like that. Here the condition, but here the one condition is mentioned, which is xi should be greater than I. x1 plus x2 plus x3 plus x4 plus x5 is equal to 30. Here condition is xi should be greater than I. That means x1 should be greater than 1. So minimum is 2. x1 should contain minimum 2. x2 3. x3 4. x4 5 and x5 6. So 2 plus 3 5, 5 plus 4 9, 9 plus 6 15 plus 5 20. So out of 30 balls, 20 balls are already placed. Now the remaining balls are 30 minus 20 is equal to 10. So here this is reduced to, this particular equation is reduced to x1 plus x2 plus x3 plus x4 plus x5 is equal to 10. Why? Because where xi is greater than or equal to 0. So this problem is reduced to this. Here xi is greater than I. So we have satisfied that condition and reduced the given equation to this. So this is nothing but arranging R similar balls into n distinct boxes with unlimited capacity. So here whose solution is nothing but n plus r minus 1 c r. So here n is equal to number of boxes 5, r is equal to 10. So 10 plus 5 minus c minus 1 c r is 10. So which is nothing but 14c 10. So here correct option is option B. A is equal to 3 1 minus 1 and 1 minus 1, and I is equal to 2 by 2 identity matrix 1 0 0 1. Which of the following matrix polynomial vanishes? Every matrix should satisfy its characteristic equation. Every matrix should satisfy its characteristic equation. That is, characteristic equation is determinant of a minus lambda I must be equal to 0. This is a characteristic equation, and every matrix should satisfy this. So here a minus lambda I is 3 minus lambda 1 minus 1 and minus 1 minus lambda. This is a minus lambda I. Determinant of this should be equal to 0. So if we simplify this, we'll be getting 1 plus lambda into lambda minus 3 plus 1 is equal to 0. So here lambda plus, this is 1, lambda minus 3 plus lambda square minus 3 lambda plus 1 is equal to 0. So lambda square minus 3 lambda minus 2 lambda minus 3 lambda plus lambda minus 2 lambda minus 2 is equal to 0. So here we can say option D is the correct option.